All right, this will be the review problems for the geometry final exam. All right, so we have our ratio and proportion here. They want us to find the length of EB. So we're looking for this length right here from E to B. All right, and we're given the ratio, so all we have to do is plug in for AD. That's this entire distance right here from A to D. So 22 plus 11 gives us 33. So in place of AD, I'm going to write 33. AE is just this distance right here. That's 22 in place of AE, 22. DC is this distance right here. That's 26 in place of DC. EB is what we're looking for. We can keep it as a question mark, or we can call it X, same thing. Okay, so when you have the fractions like set up like so, you want to cross multiply. All right, I'll do it in a different color. Top times bottom, 33 times X. And that equals bottom times top, 22 times 26. The opposite, solving for X, the opposite of times 33 is divided by 33. And it cancels here. I'll do this mess on the calculator. And rounding off to one decimal, I get X equals 17.3. Okay, these will all be multiple choice on the actual test. But that is the final answer. Make sure your answer makes sense. Number 2, in the diagram below, triangle DEF is similar to triangle ABC. What is the value of X? Right here. Okay, so trace the triangles and see if they're oriented the same way. DEF, so we're going to go DEF like that. And ABC, ABC like so. Okay, so they are oriented or facing the same way. So we can set up the fractions. All right, let's do X divided by 30. And that's going to equal 12 divided by 18. All right, so on the top, the values were from the triangles on the left, and on the bottom, the values were from the triangle on the right. Okay, the X and the 30, that was the long side on both triangles. And the 12 and the 18, that was the short side on both triangles. Okay, it doesn't matter exactly how you set them up. You just have to be consistent going across and consistent with each fraction. All right, so now you want to cross multiply. Top times bottom is X times 18. Bottom times top is 30 times 12. The opposite of times 18 is divided by 18. Cancels here, and you can do this on the calculator or manually. Divided by 6, that's 5. Divided by 6, that's 3. 12 divided by 3 is 4. And 5 times 4 equals 20. So X equals 20. All right, I canceled because I did it manually. On the calculator, do 30 times 12 divided by 18. Make sure you practice on your calculator. Okay, number 3, two similar for sale signs have a scale factor of 7 to 4. The large sign's perimeter is 105. What is the small sign perimeter? All right, so the ratio for the scale factor is equivalent to the ratio of the perimeters. All right, this is basically the ratio of the sides, the scale factor. That equals the ratio of the perimeters. All right, so we'll put the large one in the numerator since it is written first, and the small one in the denominator. Okay, large to small, that's 7/4. And the actual perimeter of the large sign is 105. All right, and we want to know the small sign perimeter, so the small perimeter, we'll just call it X. All right, this right here is the ratio, and this fraction here is the actual perimeter. Once you set it up, you're in business. Cross multiply. 7 times X, top times bottom. Bottom times top, 4 times 105. The opposite of times 7 is divided by 7. You do that to both sides, and it cancels here. 4 times 105 divided by 7 is 60. Units were in inches, so these will be in inches. Again, there will be 4 multiple choices for each problem. Final answer. Number 4 in the diagram below, what is the value of P? Okay, notice we have parallel sides here. So you want to look for the Z shape when you make the congruent angles. So you see if you make a Z like this, this, and this, the angles inside the Z match. They're congruent. So inside the Z, I'm going to match this one here and this one here. All right, so let me erase that. Okay, and of course the vertical angles, the X shape right here, this one here is congruent to this one here. And then finally, if you match 2 pairs of angles, you know the third angles are congruent. So this one here matches this one here. All right, and now you can just go across. If you go across the one with 2 marks, there's no side length, so we're not going to use these. All right, but if you go across from the 3, that's a 10. All right, across from the 3, that's a 10. And on the other side, across from 3, that's a P. Now in the denominator, across from 1, that's 18. On the other one, across from 1, that's 4. Okay, these values came from the triangle on the right, and these values came from the triangle on the left. And now we're in business. You can just cross multiply. Top times bottom is 10 times 4. Bottom times top is 18 times P. The opposite of times 18 is divided by 18. Cancels here. We have 40 divided by 18. And rounding off, I get 2.2. So P is approximately 2.2. All right. Now, you don't necessarily have to draw in all the angles and such. Okay. Just think of it as crisscrossed. Okay. You can say that, you can say 4 divided by 18 equals P divided by 10. Okay, so you basically crisscross when you make the fractions. 4 divided by 18 equals P divided by 10. All right, so that's the same thing I did, except I set them up differently. But this would also work. You would get the same answer. So you can do it the quick way if you know how to do that. Number 5, in the diagram below, what is the value of x? All right, see we have parallel lines here, so corresponding angles are congruent. So the one on the left matches that, and the one on the right matches that. They're corresponding because these lines are parallel. So these triangles are similar. We got the small one and we got the big triangle. They're similar. All right, so let's set up the fractions. So on the, let me see, we'll do the small one in the numerator, and we'll do the big one, or the large triangle, in the denominator. Okay, and for this fraction here, we'll do the sides on the left. And for this fraction here, we'll do the sides on the bottom. All right, let's see. The left side of the small triangle is this right here, that's 7. And the left side of the large triangle, that's going to be 7 plus 12. So that's 19. On the bottom of the small, right here, we got 6. The bottom of the large, right here, we got x. And now, once you're set up, we're in business. Cross multiply, top times bottom is 7 times x. Bottom times top is 19 times 6. The opposite of times 7 is divided by 7. Cancels here. 19 times 6 divided by 7. And that's 16.3, rounded off. All right, number 6, CAD is congruent to BAD. So CAD is here and BAD is here. But it's already marked on the diagram. Theta and theta, same measurement, so they're congruent. So this right here is the angle bisector theorem. Okay, and you just set up the fractions. Angle bisector, so 5.7 divided by question mark. And you do the same thing on the other side in the same direction. 6.2 divided by 4.5. All right, so make sure you go in the same direction on both triangles. Once you establish that, you're in business. Top time cross multiply. Top times bottom is going to be 5.7 times 4.5. Bottom times top is going to be question mark times 6.2. Okay, solving for question mark, same as solving for x. In fact, you can call it x if you want. Times, the opposite of times 6.2 is divided by 6.2. You do that to both sides, and it cancels here. Do this on the calculator, 5.7 times 4.5 divided by 6.2. And that equals 4.1, rounded off. So that's approximately 4.1. The squiggly lines mean we round it off. 7, in the diagram below, the 3 lines are given parallel. What is the value of x? All right, see these lines here are parallel. That means they divide both lines, both transversals, the same way. All right, so this is cutting through the parallel lines. That's a transverse, so we can call it T1. And that's cutting through parallel lines. We can call it T2. Anyhow, there's not much to it. Okay, you just do the fractions just like with the similar triangle. So 12 divided by 4. And that's going to equal x divided by 5. Okay, notice I went the same way on both triangles. All right, cross multiply. Top times bottom is 12 times 5. Bottom times top is 4 times x. The opposite of times 4 is divided by 4. And it cancels here. And this is going to be 60 divided by 4, which is just 15. So x equals 15. If you want to take a shortcut and you have the numbers that allow you to do so, 4 times 3 will give you 12. So 5 times 3 will give you 15. So that's all you have to do. Multiply both of these by the same number. 4 times 3 and 5 times 3. That's 15. All right, a triangle has side lengths of 7, 12, and 19. What type of triangle is it? Acute, right, or obtuse? Okay, the hint is to compare a squared plus b squared to c squared. So let's write that out on the, let's write a table out. A squared plus b squared and c squared. Make like a T table. Okay, so c always has to be the longest one. So that's going to be 19. So c squared is 19 squared. A and b, it doesn't matter, so I'm going to let 7 equal a. I'll let 12 equal b. So a squared is going to be 7 squared. And b squared is going to be 12 squared. All right, now you're on the calculator. 7 squared plus 12 squared. I get 193. And 19 squared is 361. All right. So 361 is greater than 193, which means that c squared is greater than a squared plus b squared. If c squared is greater than, it's obtuse. If it was equal, it would be a right triangle. And if c squared was less than, it's acute. So remember a cute little angle. If c squared is less than, it's acute. What is the value of x in the isosceles triangle below? Okay, we have two congruent sides. They told us it's an isosceles triangle. And this angle here is bisected. This one equals this one. So if you draw this segment and it bisects the vertex angle in between the sides that are congruent, it's going to make a right angle at the base. Okay, and the base becomes bisected. So instead of 10, we can make this 5 and 5. All right, so this will be 5, and that'll be 5. Okay, and we can just apply the Pythagorean theorem to this right triangle right here. So we can do a squared plus b squared equals c squared. C squared always has to be the hypotenuse across from the right angle. So 13 is going to be c. So c squared is 13 squared. All right, a and b, it doesn't matter. So I will let a equal x, and I will let b equal 5. A squared is going to be x squared. B squared is going to be 5 squared. All right. So we have x squared. 5 times 5 is 25. 13 times 13 is 169. Solving for x squared, the opposite of plus 25 is minus 25. You want to do that to both sides. And it cancels here. Bring down your x squared. 169 minus 25 is 144. And the opposite of squaring something is to take the square root. So square root of x squared is x. Square root of 144 is 12. So that's this height right in here. That's going to be 12. What is the area of the triangle below? All right, notice once again we have an isosceles triangle. This side matches this side. And when that happens, and you draw a line that's perpendicular to the base is bisected or cut in half. So the whole thing is 28. And half of 28 is just 14. Okay, so this here is 14. And this right here is also going to be 14. All right. So the area for the triangle is 1/2 base times height. We need to find the height h right here. All right. So you want to do Pythagorean theorem. You go across from your right angle. That's your hypotenuse. That's going to be C. The other two sides, A and B, it doesn't matter. So I'm going to let A equal 14, and I will let the height h equal B. All right, A squared plus B squared equals C squared. A is 14, so A squared is 14 squared. B squared is going to be the height squared, or h squared. And C squared is going to be 33 squared. All right, so 14 squared is 196. H squared stays as is. And 33 squared is going to be 1,089. All right, solving for h squared, the opposite of plus 196 is minus 196. Cancels here. Bring down your h squared, bring down your equal sign, and you can do this on the calculator or by hand. 9 minus 6 is 3. I'll make this 18, and I'll make the 10 into a 9. 18 minus 9 is 9. 9 minus 1 is 8. Probably better if you use the calculator so you don't make a mistake. Okay, h squared is 893. The opposite of squaring something is to take the square root. So the square root of 893, rounded off to 1 decimal, that's 29.9. Okay, the numbers on the actual exam might be neater than that. Okay, but that is your height. And now we can apply that to the area formula. Area is 1/2 times the base. Okay, if this is the height, the one it's perpendicular to right here, this is the base. All right, so this B was from Pythagorean theorem. This B is the actual base. See, it's perpendicular to the height. It makes a right angle or a T shape. All right, the base is 28. So in place of B, and the height we said was 29.9. All right, and you could turn this into 0.5, or you can just divide by 2 at the end instead of multiplying by 1/2. That's the same thing. So I'm going to do 28 times 29.9, and then at the end just divide by 2. All right, and I get 418.6. So that is the area, and if there were units like inches or something, the units would be squared. But again, it's all multiple choice. A triangle has side lengths of 7, 9, and radical 65. What type of triangle is it? Okay, it's just like the other problem, but we don't know which side is longest. Okay, so you want to square each one first, so you know which one to use for c squared. So 7 squared, that's just 49. And then 9 squared, that's just 81. Okay, and radical 65 squared, when you square something that's under the square root, you just remove the square root. That's 65. All right, so now that we squared each one, we can see which one is the longest side. So the 81 is the greatest out of these 3. So that's going to be your c squared. A and B, it doesn't matter, so I'll let the 65 be the a squared. And I'll let the 49 be the b squared. Okay, so we do our table once again. A squared plus b squared versus c squared. All right, a squared is 65. B squared is 49. And that is going to be, let's see, 114. And that's versus c squared, which is 81. All right, so 81 is less than 114. So that means c squared is less than a squared plus b squared. And when c squared is less than, it's a cube. All right, so that would be answer A, a cube. All right, so remember, when it's less than, it's acute. When it's greater than, it's obtuse. All right, given the similar triangles below, what is the value of y? Hint, use the geometric mean theorem. All right, so this is for similar right triangles. So you take the altitude, and that's y, and that's going to equal the geometric mean of these two. Geometric mean is actually the square root of the product. Okay, product just means you multiply. So you multiply them and take the square root. Okay, so this here is going to be the square root of 11 times 16. All right, square root of 11 times 16. Now, I'm not going to make you simplify, so you can just do 11 times 16 on the calculator. And that's 176. All right, and then just do the square root of 176. And rounding off, that's going to be 13.3. All right, so you don't have to do simplest radical form. We're just going to round off, and that will be in the multiple choices. So for the right triangles, the similar right triangles, the altitude is the square root of the product. Now, in this case, it's still similar right triangles, okay, but we don't have the altitude. We have the side length on the left, so that's x, and that's going to be the square root of this here, which is 6, times this whole thing, which is going to be 6 plus 7, and that's 13. So it's going to be the square root of 6 times 13. Again, whatever side this is on, you take the square root of this piece times the whole thing. If x were on this side, it would be 7 times 13. Okay, so depending on which leg you're on, that's which portion of the hypotenuse you use. All right, but since we're on this side, we use the 6 times the whole thing. So square root of 6 times 13, all right, 6 times 13 is 78. And the square root of 78 is going to be 8.8 rounded off. All right, special right triangles, use the diagram for 14 and 15. So they want us to find x and y. All right, and I gave you the formulas here for the 30, 60, 90. This is 90, this is 60, so this has to be 30. All right, this angle right here, 30 degrees. So, of course, we have the hypotenuse, the long leg, and the short leg. Of course, across from the right angle is always going to be your hypotenuse. And remember, the shorter side is across from the smaller angle. So across from the smallest angle, that's going to be your short side. And across from the bigger angle, other than 90, is going to be the long side. All right, now we just use the formula. You have to use the one that has the side length that's given. So since we're given hypotenuse, we need to use the one with hypotenuse in it. Okay, so the hypotenuse is 14. And that equals 2 times the short leg. The short leg is x. Okay, the opposite of times 2 is divided by 2. And 14 divided by 2 is just 7. So x is 7. And now, to get the other side, we're going to use the other formula. I'll do it in a different color. All right, and we have the long leg, which is y. And that equals the short leg, which we found to be 7, times radical 3. So it's 7 times radical 3. And there's nothing to do there. It's just 7 radical 3. All right, I'll leave the answers in that form for the multiple choices. So 2 problems in 1. Okay, here we want the value of x in this diagram here, and they gave us the formula, hypotenuse equals leg times radical 2. So this is not 30, 60, 90. We have 45 and 90, so this has to be 45 as well. All right, across from the right angle is always the hypotenuse. And now since we have a 45 and a 45, we don't have short and long. Okay, we don't have short and long because they're both the same, 45 and 45. So instead of short and long leg, we just call it leg. All right, so go across from the angle to the side, and that's just leg. Okay, leg equals leg, so x equals 5. That's it. Okay, now, I didn't ask it on this one, but in case you wanted to get the hypotenuse is leg times radical 2. So if you wanted to find the hypotenuse, it would just be the leg, which is 5, times radical 2. Okay, I didn't ask for that, but nevertheless, that's what it would be if I had asked for hypotenuse. All right, in the diagram, what is the length of CB? That's this one right here. I'll just call it X. Once again, hypotenuse is leg times radical 2. We have 90, 45, and this has to be 45. Okay, always across from the right angle. That's your hypotenuse. And for 45 and 45, we don't have short and long, so they're just both legs. All right, so hypotenuse is leg times radical 2. The hypotenuse is 5. The leg is x, and that's times radical 2. The opposite of times radical 2 is divided by radical 2. All right, and it cancels here. Now, you're not supposed to leave square roots in the denominator, so the way to get rid of that is to multiply by the denominator over itself, radical 2 over radical 2. All right, this is the same as times 1. So we have x, and that equals, in the numerator, 5 times radical 2. And on the bottom, radical 2 times radical 2 is just 2. So that's it right there. If you have a square root in the denominator, you multiply by that number over itself. All right, 18 and 19, we're using this here. And we want to know the sine of angle C and the tangent of angle C. You want to use SOHCAHTOA. All right, so for the sine, SOHCAHTOA, sine is opposite over hypotenuse. So the sine of an angle is going to be opposite over hypotenuse. That's what the O and the H stands for. This is just a Greek letter theta. You can call it X if you want. It doesn't matter. But anyhow, sine of C. All right, sine of angle C. So you have to go to angle C. You go across to the side, and that's going to be your opposite. And across from the right angle is always your hypotenuse. So we have what we need. Opposite over hypotenuse, that's going to be 20 for opposite. And hypotenuse is 25. Done. Except this, you have to reduce the fraction. These are both divisible by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. So that's going to be 4/5. Now for the tan of C, we're going to use TOA, T-O-A. The tan is opposite over adjacent. Okay, so tan of theta is going to be opposite over adjacent. All right, now it's the same angle, C. All right, if you look at the problem, sine of C and tan of C. So it's the same angle. All right, that's why I wrote tan of C. So since it's the same angle, I don't have to change the opposite. You still go across from C. That's your opposite. Across from the right angle is your hypotenuse. And the remaining side is going to be adjacent. ADJ, adjacent. All right, so in place of opposite, I plug in 20. And in place of adjacent, I plug in 15. All right, once again, must reduce. 20 divided by 5 is 4. 15 divided by 5 is 3. So that's it, 4/3 for number 19. All right, on the test, I'll give you the same angle for both, so you don't have to label the triangle more than once. Okay, what is the sum of the interior angles of a dodecagon? And in case you didn't know, that's 12 sides. All right, you don't have to memorize the names. I'll always put the number of sides. Anyhow, the sum of the interior angles is n minus 2 times 180. N is the number of sides, so n is just 12. Okay, so n minus 2 times 180. N is 12, so that's going to be 12 minus 2, parentheses, times 180. Okay, 12 minus 2 is just 10 times 180. And that's going to be 1,800. Okay, and that's in degrees. All right, this is to a separate problem right here. 21, what is the measure of each exterior angle of a decagon? That's 10 sides. Remember, the exterior angles, they add up to 360. But we want each one, so we have to divide by n, the number of sides. Since it's 10 sides, n equals 10. So that's just going to be 360 divided by 10. And, of course, that's just 36. All right, light work. If you have the formula, it's light work. If you know it, you're good to go. I'll give you this formula anyhow. 22 in the diagram below, given that DEFG is a parallelogram. What is the measure of angle F? Parallelogram means opposite sides are parallel. So the sides across from each other are parallel. Okay, and this right here, we have 67. This right here, this line cutting through, would be your transversal. Okay, you can call it T if you want. But anyhow, both angles here, angle F is the one we want. Both angles are on the right-hand side of this transversal. And if you remember, when you have parallel lines in a transversal, same side angles are supplementary. All right, that just means they add to 180. So, 67 plus this angle here, we can call it X. 67 plus X equals 180. So X is just going to be 180 minus 67. All right, that's 113. So that's all you have to do there. That's the measure of angle F. Same side supplementary. They add up to 180. In the diagram below, what is the value of each variable in the parallelogram? Okay, so these lines right here, line segments, those are diagonals. And we know that for a parallelogram, the diagonals bisect each other. All right. So this would be a midpoint on both diagonals. So this 5x equals 30. All right, 5x equals 30. And the opposite of times 5 is divided by 5. So x is just 6. Now on the other one, 3y plus 10 equals 5y minus 12. Okay, 3y plus 10 equals 5y minus 12. All right, solving for y, I like to subtract the smaller y, so I'm going to get rid of the 3y and do that to both sides. Cancels here. Since my y's are here, I want the numbers on the other side. The opposite of negative 12 is positive 12. Okay, and it cancels here. 10 plus 12 is 22. 5y minus 3y is 2y. Y times 2, the opposite of times 2, is divided by 2. And 22 divided by 2 is 11. So we have 6 and 11. So remember, for the parallelogram, the diagonals bisect each other. They cut each other in half. In the diagram below, given that EFGH is a kite, what is the measure of angle G? All right, so remember, one pair of angles are congruent for a kite, and it is the angles that are in between the sides that are not congruent. See, these are not congruent, so this angle is going to match that angle. Okay, so we can call each angle X. And remember, for a quadrilateral or four-sided, the angles add up to 360. Okay, in case you don't believe me, you can do n minus 2 times 180. That's the sum of the angles. Sum of the interior angles. All right, n is the number of sides, so n is just 4. 4 minus 2 times 180 is 2 times 180. That equals 360. Okay, hopefully you don't have to do this if you just remember the quadrilateral adds to 360. Anyhow, we have four angles now. 116 plus 40. Plus x. And that equals 360. All right, combining like terms, 116 plus 40 is going to be 156. And x plus x is going to be 2x. All right, 156 plus 2x equals 360. Let's finish it right here. 156 plus 2x equals 360. Okay, solving for x, the opposite of plus 156 is going to be minus 156. And cancels here. Bring down your 2x. And let's see, I would do this on the calculator, but 360 minus 160 is 200. That's going to be a 204. X is times 2. The opposite is divided by 2. So x is just 102. And that's in degrees. If you want to double check, you'd plug in 102 for x and add up all four. It should equal 360. In the diagram below, what is the value of x? All right, so you still have to use n minus 2 times 180. We have 1, 2, 3, 4, 5 sides. Okay, n equals 5. So n minus 2 times 180. The sum of the angles is going to be 5 minus 2 times 180. And that's going to be 3 times 180. So 300 plus 240, that's going to be 540. That's the sum of the angles. So we have to add them up and set them equal to 540. All right, so let's do each angle. I'll start with x plus 92 plus 113 plus 95 plus 127. And that equals the sum, which is 540. All right, so we have x. Combining like terms, I'm going to do this mess on the calculator. And I get 427. The opposite of plus 427 is minus 427. Okay, and it cancels there. And you want to bring down the x. 540 minus 427 is 113. So that is the final answer for x, 113.